I'm just the crazy guy who invented a programming language. The language is Seed7, and here you can see some of the features. So it's based on the C language. This is the reason I'm here. So C++, C, some relationship. And Seed7 is statically typed. It can be interpreted or compiled. It's memory saved, and it's about portability, and it's about extensibility. And well, the first question I always get is, why do you do this? Why do I create a new language? And I think George Bernard Shaw has a good description of that. I'm just unreasonable, and I think that everybody else does it wrong. And, well, my family knows me just sitting in front of the computer and doing computer-related stuff. Seed7, of course. And now let's dive in. How looks Seed7 like? And Seed7 in Seed7 all declarations use a similar syntax. You see here a keyword, then a type, then a colon, then a name, then the keyword is, and then initialization value. And here we see a variable declaration. A constant declaration has just the keyword const. If you do a type declaration, the type is type. Before it was a type, so some type like integer and so on. Now if you write type, you have a type declarations. And procedure declarations or function declarations all look the same, and with the type in front, you can always recognize what is going on. And of course, there are also abstract data types and templates, and even the syntax declaration uses also this form of declaration. And what is an abstract data type, you may question. And these are types which depend on other types. For example, arrays, hashes, or sets. So we all know arrays and so on, but usually in C, C++, in all the usually languages, the syntax and semantics of abstract data types is hard-coded, and the user cannot define some of them. And this contrasts with how Seed7 views them. So this is the actual declaration of an array. So there's a library, and this library contains the semantic declaration of an array. There's also a syntactic declaration. We come to the syntax later. And of course, here you see it's not hard-coded. And there are also hashes and sets. So there are libraries where hashes and sets are declared, and they are also not hard-coded. And let's look at templates. So we have C++ templates, and in C++, a template function can be used with parameters of various types. In Seed7, it looks a little bit different, because the template function is a function with a type as parameter, and this function does the actual declarations. So today I heard about C++ concepts. If you want to do some declarations just under one condition, you could just add some if here. And Seed7 allows you to do such things like, if this function is available, then do this declaration. And in contrast to C++ and other languages, in Seed7 you need to instantiate templates. So here are examples of the declare min max, which declares, as we saw before, a min and max function. And after this, they can be used. So if you wonder about the underline here, max 5 underline, this is big integers. So big integers can have any size, and 2 and 5 are normal integers, and p and e are, of course, floating point numbers. Seed7 has not only functions, it has also parameters, and they are called by value parameters, for example, with the val keyword, and they cannot be changed in the function. And there are reference parameter, ref keyword, and you can also not change them. And there is an in parameter. So you might question what an in parameter is, and the type defines what an in parameter is. So an in parameter can be by value or by reference, and it's in the type definition that, for example, integers have call by value and strings have call by reference. So small things are, of course, by value, and bigger things on the heap, like strings, are by reference. And you, as programmer, you just use an in parameter. So 95% of all parameters in Seed7 are just in parameters, and you don't care about. But of course, sometimes you want to change a parameter in the function, and there is an invar parameter. This is called by value, so the value is copied, and you can change it in the function, but it has not an effect on the outside world. So it's just the copy in the function is changed. And of course, there are also in-out parameters, and an in-out parameter is per reference. You can change them in the function, and it has an outside effect. And the last thing is what we have here is call by name. And this is like, in this case, an expression of a type. And the whole expression goes into the function. And let's see what a call by name parameter does. Here we have a function with a call by name parameter, a procedure, a statement, and it is the call by name parameter is referring to an expression. You can think of it's like a function pointer plus the parameters for this function. And if we call it, so if we call possibly do like here, the actual call by name parameter is not evaluated before the function is called. So for normal parameters, of course, parameters expressions are evaluated, and then the resulting value goes into the function. Not in the case for a call by name parameter. They are not evaluated before, but they are evaluated in the function. And the function can decide if it wants to evaluate this call by name parameter once, times, many times, or not at all. So this lays in the function. And let's go to something else, exceptions. So Seed7 has exceptions, and here the block exception and block statement is like a try-catch. So what we do here is this division could trigger an exception named numeric error if you divide something by 0, and here the numeric error is caught. And now we take this example from the previous slide and put it into a function. So number is now a parameter, and well, the function works for integer values. And here we have a special thing of Seed7. So this is a result variable. And this variable carries the result of the function. So at the end of the function, when the function body is finished, this is the result of the function. And here, the division number may raise numeric error. And this line at the bottom checks if a division by 0 or a division by 1 raises numeric error. But as we said here, this function works for integer numbers, and so integer values. We change it to a call by name parameter, and now it can work. So this is the call by name parameter here, function of result integer, and now the function works for integer expressions. And the expressions are not evaluated here when the does raise is called. No, they are evaluated at this place. So this way we can check with does raise if this division or the power by minus 1 raises this exception, numeric error. And until now, the function works for integer expression. So far, yes?
So this is like passing a lambda into a function, which is then evaluated later?
Not exactly. A lambda is without parameters, and lambda is like a function where you can provide the parameters later. Call by name, in this case, is an expression which has the parameters also.
Okay, I could also bind, of course, the parameters for lambda, but what the actual question here is, I have to know the definition of does raise to know if the expression is actually being evaluated at where I'm using it or inside does raise. Is that correct?
Yes. You need to know the definition that does raise defines if it evaluates the expression or not. Okay. So you need to have a look at the expression, at the definition of the function.
Okay, thank you.
So this function works for integer expressions. Why only integer expression? We can do better. We put this thing into a template, and now it works for, well, expression of a type. And a type is provided as parameter to the template. And this is a special thing because we need to declare a function of a type, and when we write this, we don't know which type a type will be, so every type has a default value, and we initialize this outcome with a default value. And how do we use this template? We just invoke it, instantiate it with integer and with big integer, and afterwards, so here it's instantiated, and afterwards we can call it this way. So we can call the division with normal integers or with big integers, or we can do the power with normal integers or with big integers. And all the things can be checked this way.
Now, if I read this correctly, and of course it's new syntax, so it's a bit difficult, you had an exception inside the function.
Yes.
But you are not propagated
no.
as an exception outside, but instead you return basically a bool to indicate that the function failed.
Yes.
So
if you look here at this code, now I walk over. Here's block, exception, catch. So here at this place, the exception is catched.
So would it be also an option to throw the exception outside the function so that...
Yes, of course.
Okay.
It works like so normal exception. It can be catched all outside also. It's just I want to demonstrate all this stuff about templates and about call by name parameters.
So that's just one option on how to use an exception.
Yes. Actually, similar functions like these are in my test suite. So my test suite needs to check when an exception is raised. And I have functions like does raise and with expressions. So I have big columns of lines of exceptions, of expressions where I need to check if they raise the exception. And I do it in a similar way like this. Okay, we already had this. Well, as I showed at the beginning, Seed7 is an extensible programming language, and this means new operator symbols can be introduced. It means the syntax and semantic of statements can be defined, and the syntax of Seed7 is defined in a file named syntax, and the statements of Seed7 are defined in the library named seed705.s7i. And let's take a look at the floating point edition. Seed7 floating points are actually double precision always, but this is just a side point. So this is the syntax of the plus, and to explain this a little bit, you need to ignore the dots here. You have to recognize that the parameters are specified with open and closed parentheses, and this leads to a pattern, and this is the pattern. So there is a parameter, then there's a plus sign, and then there's another parameter. And the parameters at the syntax level have no type, so they are typeless. And of course, the priority of the plus operator is 7, and associativity is left to right. So if you have operators of the same priority, the associativity decides which operator gets the parameters first. So this is the usual mathematical logic for plus. And now to the definition of the semantics of float. So we have a function with a result float. There are two parameters, summand 1 and summand 2, and both are float. And the syntax pattern is used here in the declaration again. So the plus here works only because of the syntax declaration we had before. And we already see here the usage, and the usage also uses this syntax pattern. So the syntax applies to the declaration and to the usage. And once we have defined the syntax of the plus operator, we can overload the plus operator with different semantics. So we have here a function with an integer result and two parameters, and in this case, two integer parameters. And you might have wondered, so we reuse the syntax, and you might have wondered, what is this int add? So these are primitive actions. So at some levels, Seed7 has to do some connections how this is implemented. And my solution is primitive actions. So this can be seen as like bytecode or something like that, so machine instructions. And an int add, for example, takes two integers and adds them. So it does not conversion of floats to integers or something like that. And having defined the plus for integers, we can define it also for complex numbers. And you see, functions can be also declared with some end-func construct. And here we have a result variable again. So this would be the result of the function, and these lines below are how a complex addition is done with real and imaginary parts. And you might think, how are these float add actions implemented? So this is actually C code in a header file, and this is the float add. And this is an object type. It's a type which can hold any value. So every interpreter has some generic object structure which can hold any value. In this case, it's named object type. And of course, a list of such object types is used as parameter. And all the prototypes of these primitive actions look the same. So they have all the same parameters. And there is a map between action name and function pointer, and this is this table. And I have this convention: action names are uppercase and the functions are lowercase. And now we can take a look at how float add actually is implemented in C, in the C code. So we have in Seed7 there are different actions, and in this case floating point actions. All these floating point actions start with FLT underline and then some name, and they are all concentrated in this floatlib file. And what happens if this is executed, we check first if the arguments are really float. So we get the arguments as object types or as generic types, and with this is it float, we check if it is really a float. So if it is not, the program would terminate. But if our declarations of the float operator are correct, this will never trigger. And then we use the take float to take the actual float out, so we get a C double value from this object type, and then we do the actual addition with the plus of C, and finally we have this build float temp. This is a function which creates an object type again from this double we have computed now. And well, this was the interpreter. There is also a compiler in Seed7. So this is the Seed7 compiler's code. And this is, now we are back to Seed7 code. And well, this is the same, similar, because all these actions have functions like this. Process function, and they get a reference to the original operator. This is not used in this case, but some functions use it. And this is the parameter list. And this is a structure for the C code. So the Seed7 compiler compiles everything to C, and then it invokes a C compiler to get to machine code. And this struct contains substrings for example, declarations, for expressions, for temporary variables, and so on. And these are merged together in the right way. And if you wonder what this and the colon equals is, this is a string append. So we actually append the stuff to this C expression dot expression, and in this case, we append also parentheses. So in the middle line, you see the plus, and around the parameters, we put parentheses, and the reason is Seed7 has operators and priority of operators, and C has the same, and they both should be independent of each other. And we do this with parentheses. And now, let's look at what you do if you want to read a single key press from a C, C++, Rust, Zig, or any conventional programming language. And for the Windows console, you use some functions. And in a Linux terminal, you have different functions to be used. And Apple has still different functions. And if we are not working in a console, if we are working graphics, under Windows we have this peak message and so on. And under Linux, there are events, and you read from the events. And if the program runs in the browser, you have to await for promises. So you see, if you want to write a portable program in C++, which should run under all this platform, it's very hard And in Seed7 it's simpler. There is a file named keyboard, and we just read from this file named keyboard, and it just works. And why does it work? The reason is simple. Seed7 has drivers. So these drivers are written in C, and you see 85,000 lines of C code is just for these drivers. And this way, your program runs the same under Linux, under Windows, or in the browser. And graphic program, or if you do sockets or do the file system, you can always do the same. There are also database drivers. And because of these drivers, the experience of programs is the same. So this is, on the left side, a native executable, and on the right side, a program which runs in the browser. And there are also libraries written in Seed7, I told. Seed7 is about portability. So on one side, we have these drivers, so libraries written in C to make portability. And on the other side, there are libraries written in pure Seed7 code. And you can read various graphics formats or archives like zip or so. You can do compressions like with deflate or gzip and so on, and encryptions as well. And now to the demo. For some reasons, I have to use a setup with 2 screens. And this means there are technical problems with my computer. So maybe you have seen this picture. And well, this is just additional information. There is a speech about Seed7 at YouTube, and this is the speech. There have approximately 5,000 views of it. So it has some slides the same and some additional slides. So there's, and here we are at the Seed7 homepage, and there is a demo section. I will just, for short, so you can do it yourself. Just search for Seed7, you click at the Seed7 homepage, and there is the demo section, and you can just click here and start programs. So in this case, and waste some time. Yeah. So I will not go into this deeper. So all these programs can be started really from here. Maybe I start this as well. So this is also a game, and you can run around and dig holes and so on. And so half of the time I'm searching my mouse.
We need a cat.
Yeah, we need a cat. So the same game we started before, we can also run locally here on the machine. And it behaves the same. So this is now in the interpreter. On the Seed7 demo page, it is compiled to WebAssembly and JavaScript. Here, it runs locally in the interpreter. But of course, if you don't want to do this, we can compile it to machine code. And run it now as executable. So it's an executable which runs locally on the machine. And let's see, I have also proof of concept, DB7. So this should be, have I missed types? Ah, okay. S7, DB7. This should come up in the browser, so I have to search for my mouse again. Here. This works like the following. The program starts, triggers the browser to open this page at localhost with the socket number, and then it plays an HTTP server. And it goes back and forth. So now we can put at the browser here, we select here, and right here, sample. Now it opened a database named sample, and we can here look into, and we can look into the contents of this table. So there is a next button and return, or we take a different one, and so on. So this is a proof of concept that from Seed7 you can access databases. And if we go back, okay, exit. At the beginning you saw there are different databases, so you can also go to Postgres, MySQL, and so on. So it supports many different databases. And now I have to go to the console again. And there is also the possibility there is also a demo program. The mouse search is a little bit. So this is another demo program which uses this kind of user interface. And in this case, you can here load some files. And from this angle, I cannot see anything. Becomes a little bit complicated. Soko. Is there Soko Ban somewhere? No, we are at Hanoi. Further down, further down. So this is the disadvantage.
So here it is. Click. Just click. Right where you are. Yes.
Yeah, and where is the start?
Left bottom. Load. Exit.
Load, yes. So here we have the source code of this program, and we can just execute it. And now we can walk around here. So this is actually the same program which you can also try in the internet at the demo page. In this case, it's called IDE7, so it's really like you load this, you have the source code here, you could change it, and if you say execute, you execute the changed source code. So if we leave here, or we can also terminate from here. So this is actually the source code of this Sokoban program. And here you see the poor man's graphics I've used. So at the time when I programmed Sokoban, I chose to do the graphics this way. And later on, I defined also libraries to read graphics PNG, BMP, GIF, and so on. And I will show you soon. So now go. Let's go back here. So the program run, in this case, in the interpreter. So this IDE program displays the stuff, and then it starts the stuff locally in the interpreter. We can also, yes?
Does it mean we are now running an interpreter inside the interpreter?
Yes. From the interpreter, you can start interpreted
so
program.
A bit of inception.
You can, yes. In the moment, I'm not sure if I start the interpreter or if I just start a new process. I think in this case, I start a process and get the process handle, and if you click on terminate, I kill the process. So it's invoking the interpreter and not, but it uses a process to do that. So let's see. I mentioned that different graphics formats, and I have a program named Picture Viewer, PV7, and this is a GIF, and it can also TIFF, or what is this, PNG? No, PPM, icon, PNG, BMP, and JPEG. And in all of these, of course, it can be resized. You can zoom in, you can pan it, pan in, pan out, and go to previous pictures also. So this is a picture viewer I have. And let's see. So if there is still some time, I can also do some live coding. Is there?
Officially 5 minutes.
Okay, 5 minutes, inclusive questions or exclusive questions?
Well, let's do it exclusive. So 5 minutes for live coding and then do some
okay.
questions so that we
so
can stretch
let's
this time.
try the live coding. So first I will go back to the home page here. And here's the benchmark section. Where is it?
Yes.
So I did some comparisons between Seed7 and other languages. And of course, there is the Sieve of Eratosthenes, and there have different language examples. And one of them is here, Seed7 code. And actually, I just I put this code into here. So this is the same code, just from this example. And now we can go here and let's say time, it's called Sieve, and we just let the interpreter run. And you see the interpreter takes some time, half of a second or so in this case. And of course, we can also compile it. So we compile it and let it a little bit optimizing. And now the compilation is already finished. And you hear the long lines here are actually calls how the GCC and compiler and linker is called. And now we can do, let's see if I have it here. No. Time, okay. I have to enter it here. So, /. So, it's now a little bit more than 10 times faster, as you see. And, well, if you do C++, you might have heard of a concept named const expression. In Seed7, you can do something similar. And here you see the code, and it computes the Eratosthenes at runtime. And if we, so where's the cut? Cut. And, well, instead of initializing with an empty set, where's the paste here? So we initialize by a call to Eratosthenes, which is the actually sieve of Eratosthenes.
You missed the closing bracket here.
Ah, thank you. I need to remove it also. So I need to do this into a const because it does not change. And this line can be removed now. Now, let's see. File. Is this a save? So we compile it again. And now we run it again. And you see it's very, very fast because the only thing which happens at runtime is the counting of the numbers. So at compile time, it already computes all these prime numbers up to 10 million and stores them in a data structure. And at runtime, it just needs to count them. So we have now a speed up of 100% or so, factor 100 or so. That's it. So now to the questions.
So thank you very much, Thomas, for the nice presentation. Are there any questions from the audience?
Did you make a game engine for all the games we've seen?
No, I did not make a game engine. I have some libraries which help for these games. And if you take a nearer look at the games, you will find out these are all retro games with a 2D graphics. So I don't have 3D OpenGL or Vulkan graphics now. I've just a graphics library which can do 2D stuff. And so this is the bad thing about it. The good thing is it's a portable library. So I define my own library for graphics, and which is just two-dimensional.
So are there any other questions? Yeah.
Why is it called Seed7? Is there also a Seed6 or Seed8?
No. I'm working on this since decades, so it's very, very old. So it's at the university, I had some ideas, and I make it my diploma and PhD thesis about extensible programming language. And I had for some time, I named it Hell. From the movie, and 2001, the movie. And then I found out I cannot name it Hell because copyright and so on. And I thought about, how I name it. And I came up with an idea calling it Eprogel, a programming something. And the idea was starting with A, you're first in the alphabet. And I told somebody about it, and he reacts with like, this is about some medicine about headaches. So Eprogel, if you have a headache, take an Eprogel. And he suggests combining a name with a digit. So, and I came with this idea calling it seed because I have some ideas, and I seed my ideas. And the digit 7 is just it sounds good. And there are 7 days. 7 is a prime number. So 7 and Seed7, both starting with an S, sounds also good. So there was never a Seed6. The predecessor was Hell, H-A-L, yeah? And it will always this way. And if you write the Seed7 program, they always start with this include Seed7 underline 05 and then S7I. And this 05 is the year when I released it to the public. So it was released in 2005, and therefore it was 05. So when I make a new version which totally different, I will just use a different name in this include file. So for example, Seed7 underline 25. So if I do it that way.
So it's basically the James Bond of programming languages.
Yes, yes.
Now, I have actually 2 questions. The first is there any code that you are aware of in the wild that uses it?
There are several people which use it. I've not found at GitHub a GitHub project using it.
Not sure if we're going to need it. And the second question, I mean, for such a language to be used, I think the important question is interoperability with other languages. I would assume C would work rather well.
No,
but,
no,
not,
no.
Not
This is a design decision I made. You know, in the C language, you have pointers. You have memory management, which is manually. You have all sorts of dangers in the C language, and therefore I decided I have a foreign function interface, but you have to write wrappers. So you can interface other libraries and other functions, but you have to write wrappers. And Seed7 has some guarantees, and these wrappers need to guarantee the stuff Seed7 does. For example, Seed7, you have automatic memory management. In Seed7 has its own strings, so you need to convert back and forth between strings used in some libraries and to the Seed7 strings and so on. So many languages have this, you can call any C function directly. And C++ does this also, and Rust does it. But I oppose this idea because this way you never get rid of the bad stuff in C. If you have 0 terminated strings, for example, you have to support them if you can call C code directly. You have to support these strings and other stuff as well.
So to make a parallel with Rust, you do not have unsafe blocks in this way.
I don't have any unsafe, so Seed7 is totally safe from end to end.
Have you submitted it to CISA for the report to list it as one of the safe programming languages?
No, I didn't. So you see, it's a big project, and the idea why I try to spread it is I want to get help. So a lot of libraries need to be written, a lot of either in Seed7 or interfacing existing C libraries, whatever. And this is so much work that you need help to do it, to reach the goal. And this is, I don't think that the people here will be convinced and starting just writing in Seed7 and supporting me. My idea is to address people worldwide. And the followers of my Seed7 stuff are really worldwide. There are some people in every continent, in every country, which do some stuff with Seed7. And I get feature requests mostly.
for...
I have some final slides. So this is Terry Davis, and he made a program, a crazy operating system, and he was really ill, but I like this wisdom that an idiot admires complexity. And this is the size of the Seed7 project, so lines of code. If you download Seed7, you get 655,000 lines in total. And this is the countries where Seed7 is downloaded, and this is just the SourceForge download. So Seed7 is at GitHub and at SourceForge, and for GitHub I don't have this picture, but for SourceForge you have this nice picture, and you see some countries use it more and some less. And this is the people who have helped me.
So then, now it's time to thank you again.
Yeah.
Session closed. Be free to take stuff from the back. We've got some snacks and drinks. Actually.